takes a stroll in cattle country. Hi, I'm Troy McClure. You may remember me from such educational films as 2 minus 3 equals negative fun and Firecrackers, the Silent Killer.
Mr. McClure?
Oh, hello, Bobby.
Jimmy.
Tell me all about Markov chains. In 1907, Russian mathematician Andrei Markov began the study of an important new type of chance process. The foundation of this process is basically that the future experiment is independent of the past, given that we are in the present. We describe a Markov chain as follows. We have a set of states, S, which is the sample space and is the set of all possible outcomes of an experiment. So S equals S1, S2, S3, and so on. The process starts in one of these states and moves successively from one state to another. Each move is called a step. If the chain is currently in Si, then it moves to state Sj at the next step, with a probability denoted by Pij. And this probability does not depend upon which states the chain was in before the current state.
Marge, can I go outside and play?
Markov models are extensively applied to everyday life. They are used to model the weather and help with languages, particularly voice recognition software. I am going to demonstrate a Markov model using a very simple example of orange juice sales. Suppose an orange juice company, which controls 20% of the market, hire a market research company to investigate what would happen if they launched an aggressive advertising campaign. The research found that if the campaign was to be launched, people who already bought brand A juice would be 90% likely to keep buying it after the campaign. And someone who did not previously buy brand A orange juice would now switch to buying it with a 70% likelihood. This information can be demonstrated by a transition diagram as shown. This demonstrates the relative possibilities. Also shown is a transition matrix. You may or may not yet be familiar with these, but you will be expected to construct these in the future. So I've included it for future reference. Or A. Howard provides us with a picturesque description of the Markov chain as a frog jumping on a set of lily pads. The frog starts on one of the pads and then jumps from lily pad to lily pad with the appropriate transition probability.